Hello everyone. So today we'll start with another new concept called as operating system services, which is another important concept. So this is also usually asked for 10 marks along with the definition of operating system. So we have one of the important diagram for this concept. We all know that we have a user, we have an operating system and the hardware. So one thing we have to remember here is when the user is there, it is interacting with the operating system so that it can have the access to the hardware. To remember these services, there are totally 9 services. So to remember, you can just have one of the sentence which I have already framed. It's just a sentence so that you can remember the initials of each service. It's like you and I will first protect PC era. So UIFP PCERA. So if you do this, you will remember these services. One is first one, that is user interface, which you can see here. You have a user interface. Now, whenever the user wants to interact with the hardware, it is in common that it has we need an interface to have the access because we don't know how exactly we have to interact with the hardware. Okay, so first thing you'll have user interface. Now in the user interface, it's very common that you people know we have CLI and GUI. Okay, so CLI is nothing but one best example here I can give is your command prompts, where we just go on giving the commands and based on that you are interacting with the system. Whereas the GUI is nothing but your simple example is your Windows, which is like you just to open any of the application you just click, right click, like that. Okay, so this is about your user interface. The next, that is U is done. You can take it in according to order, or you can mix it up also. Okay, because these are services. Now I is nothing but it is standing for input output operations, this one. So here input output operations is nothing but for this we are using input output operations, like say whenever any programs we are running, and for that program we need some input devices or output devices to be used. So such resources can be used only when we are interacting with the hardware. So that input output operation services is being provided, that is by running, or if we say running any program may require any input output, user cannot control input output devices directly, correct? So therefore the OS will be providing all this services. Now coming to the next, you just skip off this will. We have F, that is file manipulation. Now when I say file manipulation or file system manipulation, it's nothing but how you are organizing your files, your directories, your what time you have created. All about this details is maintained in your file system manipulation. Now next we have protect. You can take this entire word here, that is comes with the next service, protection and security. It's simple as the name itself says, whatever the data or everything what we do must be protected. So if we talk in terms of process, several different processes will be executing. Say suppose that they are executing at the same time, so where it should not be such a way that one process is going to interfere with another process, so that interference should not be done. So that way we have to protect the processes also. So all access to the system resources are controlled, and by the term of security we can say where system is not being accessed by the outsiders. So that is how you are going to define for your protection and security. Now next comes is P and C. For P you can denote for program execution. Now, when I say program execution, it's simple how you're going to execute your program. Say your program is written in your source code, correct? Your source code will be compiled through your compiler. Okay. Now, when the compiler is compiled, it will generate one of the file called obj file or object file, and then it will generate a .exe file, that is executable file. So after that executed, then you will be getting your output. Okay, so this is how you have for your program execution. That means the OS is providing uh, for execution of the program, it must be able to uh, it must be first loaded into your main memory for any of the program execution. So that is for your P. Now coming to the next, we have C. C stands for communication. Now communication, by the name itself, it says that say suppose we have to know the communication between the processes can be within the same computers or within different computers that are connected through network, and this is controlled by operating system. Now this communication may be implemented via a shared memory or a message passing, which you will be seeing in the next module. So next we have E, that is E standing for your error detection. Now when I talk about the error detection, OS has some capability to detect some of the errors and correcting the errors also. So they may occur any errors. So like say hardware error or software error. For each type of the error, OS should take an appropriate actions. So that is all handled by your operating system. Maybe at such time or such error, it like say suppose as I said, if the errors occurred in the program which are running in the kernel mode, it may crash the whole system. So like that, the errors that are generated will be handled by your operating system. They will be handled and detected. Now coming to the next, we have R, that is your resource allocation. Now when I talk about the resources, it's nothing but your hardware, your memory, say about your input output devices, all comes in your hardware part. Okay, those whatever the resources are being provided, we should be allocating those resources in a proper way for the processes that are executing. So allocating the resources to the process for any of the different use must be done in a correct way, and that is all being handled by your operating system. And this is nothing but like say you have some algorithms also for this, so you will be seeing it again in the next module. So here you can just write that every process requires a certain resource at say about certain point of time. So OS allocates these resources that are required by the processes and that are waiting for or asking for the resources, but in an efficient way. So that is how your resource allocation point can be defined. At the last, we have accounting. Now, when I say about accounting, it's nothing but we have to keep track of which user use how much of the resource or what kind of resource that is being there in your or being provided. Okay, so that is all keeping of records of which user uses how much and what kind of resource and how long it will be maintained. So by keeping such records, it can be valued too. So that recording of or maintaining of all such data is done by your operating system. So that can be defined for your accounting. So this you can write total 9 points for this question along with this diagram. So I think this would be enough for your 10 marks question. Okay, so we have the next important concept called as a system calls. So this concept is usually asked for 5 to 7 marks. If it is asked for only 5 to 7 marks, you have to just write about the definition and a little bit about what exactly is a system call and with the example. Okay, so that will fetch you your 5 to 6 marks. But if some question papers they have asked for 10 marks. So what to write for 10 marks here? So when they have asked for 10 marks, you have to even write the types of system calls also. So first I will be just covering with the 5 to 7 marks concept, and then we'll cover with your types of system calls. Here in the system call, now I can say a definition. I mean, what is the first point that you have to write is a definition. It says that it provides an interface to the services made available by an OS. That means a call. Okay, now say for an example, as I had taken an example in the previous video, that your mom is calling you in between of you reading a novel, while you were reading a novel. Okay, so while you were reading a novel, your mom calls you and tell you to do some work or something, some task is being given to you. So that interrupt or that call which is made is called as a system call. Okay, now say suppose for an example, um, okay, one example I'll give you all. Now you want to go for some trip, but you know your dad might not allow. So how do you convey it to your dad, or how do you convince it to your dad? Most of them, they go through the mom. Okay, they go and inform to mom and they say that mom, I want to go to a trip, you please convince somehow to dad and tell him to give some permission. So that is how you are acting like a user. Your mom is acting like an operating system. Your dad is in a kernel mode. Okay, a hardware which, you know, how everything can be executed. So same here, that what you are conveying your task to be done, that call while you were in the routine, you got one trip to go. That trip is one of the interrupt kind of which you have to execute. You want to go, so to go for it you have to ask the permission from the dad. Okay, so that cannot be only permitted from yourself and you can go, correct? So same way here also in the operating system, if any interrupts the such kinds if we get, we are going to have the access to the hardware. So if the program is executed, now say suppose that program which is there in your user mode. Now we have already discussed about your user mode and kernel mode in your dual mode operations, if I'm not wrong. So we have kernel mode and we have user mode. Now we know all the user programs which are there, that is not having a direct access to your memory or your hardware, correct? So whereas the kernel mode has the access to the hardware or your memory directly. So therefore we call this kernel mode as a privileged mode and this user mode is a safer mode. Now why do we call this as a privileged mode, and why we prefer, or why do we say that the user mode is a safer mode? Now whenever, if suppose, if we are, say for an example, just a scenario, if the program we have to execute, if that program is in the kernel mode and it has started its execution, and as it has a direct access to the hardware or your memory, say directly, maybe while the program is executing, that program gets crashed. So when that program which is there in the kernel mode gets crashed, there is a chance that your whole entire whole entire system might get crashed. So that is the reason we call this is as a privileged mode. Now, so that no other program have a permission to execute here. Okay, because this is what will happen if any program comes in the kernel mode and it gets an error and it gets crashed, there is a chance of entire system getting crashed or halt like that. So therefore we call your user mode as a safer mode. So whenever the user applications are run, that are all being run in your user mode. Only while any services that needs to be executed from your user mode, then it will be contacting with the OS, and that OS in turn will be contacting your hardware or a memory, and then it will execute your services. Okay, that is the user services. Now this process of switching from one mode, that is from user mode to kernel mode and kernel mode to your user mode, which we saw in your dual mode operation, that process is called as a context switching. Okay, so the switching among these two, that is user mode to kernel mode or kernel mode to user mode, is called as context switching. So you have to explain first the definition, draw this diagram, say there is a user mode and the kernel mode. In the kernel mode, it's a privileged mode and it has a direct access, whereas user mode do not have a direct access, so it's a safer one. And switching from one mode to another is called as a context switching. And therefore, we whenever want, while the program is executing in the user mode, and if it gets any interrupt, that interrupt may be in need of some of the resources. So when it is in need of some resources or the services, it has to make a call to the OS, that is, and that call will be going to your kernel, and that kernel will execute that services, and reply or result will be given to your user mode, and the process will be continuing with the execution. The CPU will be continuing with the process. Okay, now after this you have to define, I mean, you all got to know about the definition. You can even define it as nothing but a way in which the computer program, that is the user program, will be requesting some of these services from the kernel, okay, to execute that service. So that service will be executed from the kernel, which is nothing but the kernel is of the OS only. Okay, so only we call the kernel as the heart of the operating system. Now these system calls which are there, they are available in the form of a routines, and they are mostly written in C or C++. So you have got a 3 points to write here. Okay, so at least 3 marks are fetched here. You can draw this diagram, or you may need not draw the diagram. It's left to you. Like, it's not that necessary to draw this diagram. Now, coming to the next, as I said, if it is asked for 5 to 6 marks or 6 to 7 marks, you have to define about the system call, you have to write about the context switching with the user modes, and then you have to explain about one example, I say. So when I say an example, here in your textbook, it's already been given with one example that says writing a simple program to read the data from one file and copy them or copy that to another file. So it's simple copy paste actually. So you might feel that this copy pasting is very simple and it takes no much time. Correct? Obviously it takes much, it will not take much time. You know, it's just a fraction of seconds or a fraction of minutes. Okay, but internally, how are these being working through your OS? That is what we are going to see. Now suppose we have a source file, that is, when I say source file, it's that the file that has a content that needs to be copied, okay, to the destination. Okay, now we have a destination file also. Okay, this destination file is nothing but the content of the source file that needs to be copied and pasted into the destination file. So to do this, there are many system calls that will be executed while this task is executed. So firstly, so your what system calls will be called here. Now first thing what you do is, first you have to know what is the input file that needs to be copied, or what is the file name. You should know from which file name I should copy that content first. So first thing what you have to do is, or the first system call will be acquiring what? Input file name. So you should know what is the file name of the source file from which the program needs to be, or the content needs to be copied. Now acquire the input file name. Now you might have seen in some programs you may have a printf statement, enter the number of columns, enter the number of rows. So that prompt should be seen on your screen, then only I can enter that input file name, or I can search for the input file name. So same way here, one system call will be called to know which input file should I search for the content. So that file name should be asked. So your prompt will be seen. So you have to write that prompt on the screen. Now after say that is been, enter the input file name. Say suppose that might be the prompt. So that is one of the system call is generated here again. So it will ask the user side, the kernel will ask what input file should be opened, and then you write some input file name maybe, so that will accept your input. So IP is nothing but, I'm just using a short form here, IP is input. Okay, now once you have accepted the input file name, you should also know where should I copy this file, this content of this file. Okay, what you have entered. So you should acquire what? Now I should know about what is the output file. Okay, so you need to know about input file also, output file also. Now first thing I have to keep open which file should I have to copy to which file. So first I have to need a input file, and that will be displayed, and I write an input that will accept. Then to which file should I copy? To, you have to mention again the output file name, and that output file name, how do you mention or how do you give? You will not understand until unless you've been given there. So same way the operating system, again it will generate a system call and saying, asking for what output file should I have to copy to. So that again it will accept whatever the input you are giving as a output file name. Now after that, what you should do to copy the content of this input file, I have to open that file. Correct? So without opening the file, I cannot see the content. So again one system call will be called saying open the what? Input file. So we have to open the input file. Now when we have to open that file, to open that file, before opening we have to check with one condition. Say if we have to know whether that file which we are asking for the input is really there or no. Correct? So while we are trying to open this input file, it has to be checked whether the file exists or doesn't exist. If file doesn't exist, then what we have to do? We have to abort. That means the operating system, say suppose it is accepted your input and it will search while you say open system call. Maybe it did not find that file anywhere in your system, so it will abort, it will not open. You will get a one dialog box, you remember, this file does not exist, like this. Okay, if it does not exist, maybe you want to then check for some other file or create an input file. Now you have to create a file. Now when I create this file, okay, now while creating the file, what file name you give? Okay, if that file exists, then again you have to abort. Again the system call will be called. Operating system finds that after creating that file, it is finding with some file with the same name. So again you might get one system dialog box saying that this file is already existing, so please create some other file name, use some other file name. After that, it will, maybe you have not got any other file with that same name. Then when you find that file, say suppose file exists, then I have to switch to some other system call. Now what will happen? We have to read that content from the source file to your, and then write it to the output file. So one is the system call read. What you have to read from where? From input. Okay, from input file. So here is one system call being called, and then after reading you have to write, or what you're copying is nothing but a reading. then you're writing it to your output file. Okay, that is your destination file. Now this reading and writing will be continued. Now I will create a loop here. While loop? Now till end of the read file. So until where? Until read fails. Now why read fails? The system call will see until the end of the file. You remember EOF, that is we have to be reading, keep reading the entire file until there is nothing to be read. After that should be in the loop. So this reading and writing. Suppose there was a reading, say ABC here, you write and you pasted in ABC here. Like that again you have to go on doing everything until end of your file. Okay, now this will be in your loop. Now after that you're done with reading and writing. Now you have to close the files. So first I will be closing your both any output files or input files. So you are closing it, and once you have closed your output file, you have to intimate that you have completely copy pasted or read it from your source file and you have written it to your destination file. So you have to write a message to the screen saying that or one system call will be given to from the operating system, saying it will display a message to the on the screen saying I have completely copy pasted. Now after that there is one more system call that will become terminate normally. That means you're closing that file, I mean that process, you're ending. Okay, so once your process is ended, that process is terminated successfully. So this is one example which you have to write. Now to remember how we have to write these system calls, it's simple. How do you write? You open step by step, you're just going to write it. Think that this is one program you have to write to open a file and read the content and copy it to the file. So if it is like that, then how you write a pseudocode and an algorithm, that way you can write these codes, I mean your system calls. So each step here has a system call that is being called. So you just imagine how many system calls are being made. Now these many system calls are made only to just read the file from one file to and write it to another file. So in this way, there is how your system calls work, and this is how your process is executed. Now next, after this, we will be seeing your types of system call. In this types of system calls, you need not have much about this, but usually if they have asked for 10 marks, so it's never asked, but only once they have asked for 10 marks. So your types of system calls is also important. Here, how to remember about how many types? First, you should remember there are 5 types. Okay, now one short form to remember the types or only just the initials. It's like PDF of ICE. Now I have written ICE but not E. So here PDFIC, only these I'm going to take. So first one for P, that depicts process control. Then for D, you can write device manipulation. Okay, then we have what? F, that is file manipulation. Then we have ICE, PDF of ICE. Just to remember, I'm just using some of the tricks and terms so that it will be easiest, because as it's a theory, it's very difficult to remember the concepts. So then whenever types of system calls come, you should remember PDF of ICE. We are doing PDF of ICE in this types of system calls, like that. Okay, now for I, it's an information system, information maintenance. Okay, so then For C, it's nothing but your communication. Now, when you remember these, so you hear nothing to be explained here in the types of system calls. Here, what you have to explain is the system calls are being categorized into different types, that is process control and file manipulation, like this. So you have many different examples for this. For controlling of the process, we have to end the process, we have to abort the process, we have to execute, you have to create the process. So like that you can write many system clause, say creating a process, aborting the process, then ending the process, or end, execute. So these are all related to your process control. Okay, so that there are many other system calls which you can write it here. Okay, write at least about 6 to 7 system calls for each types. Okay, so it will be better, like get process, like that. So you have many different system calls here. Okay, so for device manipulation, now when I say device manipulation, it's like you have to write the attributes of the devices. Okay, like that, get attributes, I mean get device attributes, then read about that, then you can say request a device. Okay, there are many things, these you have to understand or you have to remember. There is no other, release a device. So there are many different system calls for your device. Okay, now when I say about file manipulation, you know about the files, you have to open a file, create a file, delete a file. So like that, create file, delete file. So you can give any, many this thing system calls here also. So open, then close, then abort. Again here there are many system calls for your file manipulation. Now for information maintenance, it's about all what we have to gather the information about that process. So when that process was created, so that means the date, time, set date, get system data or get date, like that. So you can say get time, set time, then get date, like that. Okay, so something about information which you want to fetch, so that information will be nothing about just then getting about the data about that system. So get system data, set system data, like that, get attributes, like so many system calls you have to write it here. Now again, for the communication, it's nothing but connections, like how you communicate. So that can be, main thing is you're sending and receiving the messages, like that. So send, receive, then transfer. You have many other system calls here, you can refer the textbook, but try to write at least 6 to 7 examples for your types of system calls. So this makes your entire 10 marks for your system calls. I hope it helps. If anything like that you all want to cover any of the concepts in this first module, please do comment, so that I will try and upload that part of the concepts also. Hope it's helping you people. Thank you so much. Please do share and subscribe. Thank you so much.